In solving a quadratic inequality such as this, you could either use the graphing method or the algebraic method. I'm going to show you two quadratic inequalities. I'm going to solve the first one using the graphing method, and then the second one using the algebraic method. First, the graphing method. Given x squared minus 4x minus 5 is less than 0, we want to find the x-intercepts first. To find the x-intercept, I'm going to factor where it's going to be x minus 5 times x plus 1 equals 0. And solving for x, we get 5 or negative 1. So here's the negative 1. Here's the 5 that we want. And here's the important thing. When marking the x-intercepts, they're going to be either closed circle or open circle. If it's less than or greater than sign, it's going to be open circle, meaning it does not include the x-intercepts. If it's less than or greater than, it's going to be a closed circle, meaning it includes the x-intercepts. In this case, it's less than 0, meaning it does not include the x-intercepts. So I'm going to draw or mark with open circles. Next, in order to draw the parabola, we do need a vertex. However, remember, we're only solving this quadratic inequality where we want to find out where it is less than 0, meaning where it is below the x-axis. So we're not actually interested, or we don't need the vertex in order to solve this quadratic inequality. So I'm going to skip finding the vertex because it is unnecessary for solving the quadratic inequality. So let's go ahead and graph this quadratic inequality or the parabola. But before we do that, notice that the coefficient of x squared is plus 1. When the coefficient of x squared is positive, it means that the parabola points upward. Therefore, the parabola is going to look like this. Not a perfect parabola, but does the job. Next, I'm going to shade where it's less than 0, or once again, below the x-axis. Hopefully that's enough shading for you. Then, since the portions that are shaded, or the green lines that you see, is between negative 1 and 5, our answer is going to be x is greater than negative 1, meaning right of negative 1, and less than 5, meaning left side of the 5. So there you go. To solve this quadratic inequality, what we did was find the x-intercepts, graph the parabola, and then once we graph the parabola, we figured out that the graph where it's less than 0 is going to be between negative 1 and 5, and we got the answer right here. So let me do another example using the algebra method. With this example, I'm going to be solving it using the algebraic method, meaning without graphing it. First, I'm going to add x squared to the left and the right side, and also switch the order of 50 and the 15x. Like that. Next, I'm going to factor this. And I'm going to take that x minus 5, set it equals 0 and solve. And then take that x minus 10, set it equals 0, and solve. As you can see, the 5 and 10, had we graphed this, would have been the x-intercepts. But instead of graphing it, I'm going to draw a number line and then write down these 2 points, 5 and the 10. And I'm going to mark them with open circle because it's greater than 0. If it was greater than or equal to 0, once again, would have been closed circle. However, for this example, it's going to be open circle. Next, I'm going to pick some numbers on the left side of the 5, between the 5 and the 10, and the right side of the 10 to see if these portions or which portions would actually be greater than 0. So let's start by picking a number on the left side of the 5, and we could pick 4. If we were to put 4 in here, so I put 4 here and here, you end up getting this, which is going to be -1 times -6, which is +6, and it is greater than 0. So I'm going to shade left side of the 5 and even write down the word yes. Next, I like to pick a number between 5 and 10, and let's pick 7. This time, I'm not going to actually calculate the numbers. I just want to see if it's going to be greater than 0, meaning if I do 7 minus 5, I'll get a positive number. If I do 7, excuse me, if I do 7 minus 10, I'll get a negative number. Negative number times a positive number times a negative number will be negative, and a negative number is not greater than 0. Therefore, I'm going to put the word no between 5 and 10. Lastly, let's pick a number on the right side of the 10, and let's put 11. So I put 11 for x, 11 for x. Once again, instead of calculating the actual value of the number, we just want to find out the signs. 11 minus 5 is going to be positive, and 11 minus 10 is going to be positive also. Positive times positive is positive, and of course, positive is greater than 0. So let's go ahead and shade right side of the 10 and even put the word yes. Then our final answer will be x is less than -5, or x is greater than 10. In case you're interested in representing or writing this as an interval notation, the answer will be this. Since that left arrow represents -infinity, it's going to be -infinity up to 5. However, since it does not include the number 5, it's going to be parentheses. And by the way, infinity is always parentheses. And whenever you have the word or, meaning where they do not intersect, it's going to be a union sign. And then we start from 10. Again, it's going to be parentheses because it does not include the number 10. And it goes to positive infinity. So we could put infinity here or positive infinity, whichever you like. And again, infinities are always parentheses. So there you have it. You could either put the answer in the inequality form like this, x is less than -5 or x is greater than 10, or you could put it in the interval notation form as well. So then I've showed you 2 examples. First one using the graphing method to solve the quadratic inequality, and the second method is by using the algebra or by checking or testing out the numbers. As a bonus, let me show you one more example. In this part of the lesson, I'd like to show you how to graph a quadratic inequality. Before, we were solving the quadratic inequality. Here, we're going to be graphing the quadratic inequality. The two are different. In our previous 2 examples, we had where we had the quadratic, such as x squared minus 3x plus 2. However, it was greater than 0. Notice there's no y in the inequality. When we have something like this, that's where we solve for the quadratic inequality. However, in this example here, we have y is less than x squared minus 3x plus 2. When we have the variable y involved, we're not solving the quadratic inequality. We want to graph, or we want to solve by graphing. And we could only show the answer by graphing. Let me show you what I'm talking about. First, if we were to set the equation y equals instead of the y less than, then we end up getting this. Then let's go ahead and graph this parabola once again by factoring, where the x-intercepts will be 2 and 1. Let's go ahead and mark that. So the x-intercepts will be at here and here. Notice that here, it's always going to be just a closed circle or a dot when we're graphing the inequality. Next, we did not do it before, but when we're solving, or when we're graphing the quadratic inequality, we need the exact vertex. And here's the way to find the vertex. The x-coordinate of the vertex can be solved, or can be found, by adding the x-intercepts and simply dividing it by 2. Where in this case, it's going to be 1.5. Then to find the y-coordinate of the vertex, we need to take that 1.5, plug it into either one of the equations. Let's go ahead and plug it into the second one. (1.5 minus 2 is negative 0.5. And 1.5 minus 1 is positive 0.5, where y is going to be negative 0.25. So I'm going to mark the vertex on the graph. So right there. So we have the x-intercepts at 1 and 2, and we have the vertex at 1.5 and negative 0.25. When graphing an inequality, you have to be careful about this. If it's less than or greater than, you're going to be graphing with dotted lines. If it's less than or greater than, less than or equal, and greater than or equal, it's going to be with solid lines. In this case, it's y is less than, so we're going to be drawing the parabola using dotted lines. Like this. Finally, we need to shade either above the graph, meaning inside the parabola, or outside or below the parabola. Since the sign, the inequality sign, is less than, we're going to be graphing below the parabola or outside the parabola. Like that. So remember, when it's less than or greater than, make sure you graph the parabola with the dotted line. And when it's less than, it's going to be below, which is outside the parabola. However, if it's greater than, it's going to be above or inside the parabola.